we took the trip down memory lane last night or this last weekend with the sequences, arithmetic sequences. Hopefully you did that. Some of you did, some of you didn't. Not a wise choice if you didn't. I do want to take a look at this notation here. Maybe I should back up and, well, no, we'll just go from here. Geometric sequences are based on what mathematical operation? Arithmetics are based on the adding. Geometric is based on what? Multiplying, right? So this is all about multiplication. Every time we're multiplying by the same, they use this phrase, common ratio. So what letter do you think they use for common ratio? R, thank you very much. Okay, you know, D for difference, R for ratio. So take a look at this particular sequence. It's important for you to understand. It will be helpful in different types of problems to understand this process. You start, nice haircut, by the way. You start with the letter A. Okay, well, it's some number of the universe. It's just a number. It's a starting place. What happens to go to the second term? What do you do to get to the second term? You multiply by what? R. What do you do to get to the third term? You multiply by R again. Now, multiplying by R twice is the same thing as multiplying the original value by what? R squared. Can you tell me what you think the fourth term would be? A times R cubed, right? Because in order to get to that place, you would multiply by R again. Well, this pattern can continue a long way down the road, and somewhere out there in the universe is what they call the nth term. In other words, this is a formula. Now, what is that formula? Maybe I should write that out somewhere over here. Let's see here. How about T sub n equals first term, we'll call it T sub 1 times R to the n minus 1. Now, sometimes you'll see me use A sub 1. A sub n, A sub 1. T sub n, T sub 1. G sub n, G sub 1. Does it really matter? Absolutely not. But I forbid you to use n sub n. Okay? Red pen of death will not be kind to that choice. Okay? Don't be going off on me with that. You can pick X sub n, Q sub n, H sub n. I don't care what you want to call the sequence. By the way, this would this be an explicit formula or recursive formula? This would be your explicit, folks. This is the one that will be more useful to you because you will be able to find any term of a sequence that you want to. If I asked you to find the 500th term of a geometric sequence, you better believe you're going to use this one. The recursive one has two parts to it. It has to have a starting point. You have to have a number to start with. And then there will be a pattern of what to do to find the next term. Now, personally, a lot of times I like to put the multiplier in front of that right there. It's a lot, it's cleaner, it's easier to read, fewer mistakes get made, kind of thing. Recursive patterns are useful for finding the first 5 terms. Not so useful if you want to find the 500th term. If you want to find the 500th term with this particular pattern, you would have to know the 499th term. In order to know the 499th term, you have to know the 498th term, and the 497th, and the 496th, and it's a big mess. There's no way I'm asking you to use this formula with the 500th term. Now, there are some sequences out there which only have a recursive pattern. They don't have an explicit one. But the ones we're going to focus on have explicit ones, so use the explicit formula when you need it. So, we can find the common ratio. Now, when you find a common difference, you take any term and subtract the previous one. But how do you find the common ratio? How do you find the multiplier? Any term divided by what? The previous one. Any term you want divided by the previous one. Probably should write that somewhere. Any term divided by the previous one. We taught you that last year as well. And so the multiplier in this case is what? 2. We're multiplying by 2 every time. We're not going to find the 10th term next. I don't like the order in which they're asking you these questions. I would rather find the explicit formula next. Okay, so yes, I'm going to do A, B, C, and D, but just not in the order they've asked. So, I think you should fill in those 2 blanks. I'll come around the room and see if you have done it correctly. Fill in the 2 blanks. That's part of the formula, yes. Nice. See, I like it. Got the starting term, multiplier. Now, we know what that number is. We know what that first term is. Good. No. We are substituting that number in for the first term. Yeah, perfect. That's the formula I want. Good. Okay, now we know what the first term is. Look up there and tell me what the first term is. So we can substitute. Yep, exactly. Perfect. Yeah, it's true. I'm writing this stuff down, but you are correct. Oh, you can find this video. It will be on my Gumroad channel once I do the Ed Puzzle. This particular one will be posted on the Gumroad. Okay, it'll be in the long list. The new one tonight is on Ed Puzzle, and then after everybody gets the credit, then it'll be slid right into the Gumroad. So it's all in one place. Nice. Oh, switched them. But so, first term is
this is the R.
Correct. So the multiplier is 2, according to the explicit formula. Remember, the explicit formula is this pattern up here. So it goes first term, and then the ratio to the n-1 power. You got it? Okay. Hopefully you put in the first term and the common multiplier. All right, can we find the 10th term? That was what they wanted me to do in part B, and that is a horrible parenthesis. They want to know the 10th term. What do you think we should do? Plug in a 10. Figure it out. Okay, for those of you who got the right answer, because several of you, I saw your work, is this going to give you the same answer? Is 6 to the 9th going to give you the same answer? Nope. What did this person do wrong?
They multiplied 3 by 2 in verse.
They multiplied before they raised to an exponent. Right? That's a violation of the order of operations. In some countries, you use a hand for that. Do not do that. Okay? Besides, your calculator knows the order of operations for you. So, make sure you just type it as is, because 3 times 2 to the 9th ended up giving you 1536, correct? Okay. So the last part of this was part C, find the recursive formula. Remember, there's 2 parts to the recursive formula. You have to have the starting place. I guess I'll use a T just to be, you know, the same as what we had before. It really doesn't matter, though. And we're multiplying, so just like I said earlier, we'll put our multiplier in front. But you need to fill in the blanks. Do all the formulas come on the test? Sure they do. I was going to say, it's like she used one side to be on the other one. Okay, I'm confused. I got you. That's okay. I'll make all kinds of bad scribbles. All right, what did we put in the first one? 3. And about the second one? We need the multiplier, right? Because you're telling me that you're taking 2 times the previous term. Did you know your calculator handles the recursive pattern extremely well? Did I do that in the video? Did I? Yeah. Oh, yeah, didn't watch it. You don't think I did? Okay. All right, so let's show you how nicely your calculator handles the recursive pattern. This is true for any scientific calculator or graphing calculator. So you start with the first value, you type a 3, you hit the enter button. Next, I'm telling the calculator what to do to the previous answer. So I'm saying answer times 2. When I hit the enter button, it tells me that the second term is 6. When I hit the enter button again, it tells me the third term is 12. When I hit the enter button again, it tells me it's 24. So you can see that I can just keep doing this for a long time, right? I can come up with terms fast. But if I'm asking you for the 500th term, that's not a good way to do it. You're not going to get the credit if we are going to go that way. You've got to use the explicit formula to find the 500th term. Of course, this one, the 500th term, would be a little bit on the large side, so we're probably not going to find the 500th term using our technology. Could we do it with an Excel spreadsheet? Probably. But the technology has to be able to handle the values. And there's limitations to your graphing calculator, but the recursive pattern is very easily handled by this graphing calculator or even the scientific calculator technology. Okay, let's go to that second example here. First of all, I need the multiplier. Any term divided by the previous term, which pair do you think would be a good one to use? Yeah, I like that choice right there. That's a good one right there. Any term divided by the previous term. What do you get? Yeah, it's 100, right? 10 squared. I don't care. And I don't care if you write 10 squared or 100. It doesn't matter to me. Subtract the exponents, right? Okay, so that was A. Explicit formula. Find me an explicit formula for that. Go. Yeah. That's right on my desk. And it was bothering you all weekend. That's why you emailed me, right? You didn't notice. What? First a water bottle, then a calculator. What's next? Car keys? Okay. What'd you start off with? T subscript n. Sure, that's a good way to start. Equals. Now, I don't care if you started out A subscript n, as long as it's not N subscript n. That's a sin. Okay, so T subscript n is equal to something times something to the n minus 1. 10 to the negative third, okay. And once again, if you decided to put 0.001, I don't care. That'd be fine. Okay, times what? 100? Yeah, sure, that'll work. First term, common ratio. Okay, then they wanted the 10th term. So the 10th term, it probably would have been easier if we'd have left that 10 squared, because then we would have had 10 squared to the 9th. What is 10 squared to the 9th? What are you allowed to do with the 2 and the 9? The power of a power property. What are you allowed to do with the 2 and the 9? Multiply them, thank you. So that would be 10 to the negative 3rd times 10 to the 18th. When you are multiplying like bases, what are you allowed to do with those exponents? Add them together, right? Negative 3 plus 18 is 15. For those of you that typed it on a calculator, you got 1E 15, didn't you? Do you know what you just found? Scientific notation, right? So you just found 1 times 10 to the 15th. If you write this, I'm okay. If you write this, I'm okay. Don't give me that crap. Interpret what your calculator is telling you. You're capable people. Okay, now recursive formula. Write your recursive formula. Show me what you get. Nice. I like it. You can write 10 squared. You can write 100. Identify the rule correctly. I don't care. It's fine. So if you have both parties, you're okay with that. Yep, good. Seeing a lot of good recursive formulas. Ooh, toss it 0.001. Different. Good. Whoa. So lots of you doing good things there, either 10 to the negative 3rd or 0.001. T subscript n equals, I don't care if you put 100 or if you put 10 squared, it doesn't matter to me. Some of you did 10 squared, some of you did 100. Okay, moving on down the road. 1, 2, 3, 4, 5. The second term and the fifth term are 3 and 24. They want me to find the explicit and recursive formulas for the sequence if we assume it's arithmetic. Okay, don't be one of those people at the parties that says arithmetic. Okay, that's a noun, right? This is an arithmetic sequence. Arithmetic would be an adjective. Yes, I know a few things. Okay? Now, how do we find the common difference? Since this is arithmetic, we're looking for a common difference if we do not have consecutive terms. I guess my question is, how many times do you add the common difference D to get from the second term to the fourth one or fifth one? How many? Yeah, you're right, but hold on to that thought, okay? How many times do we add the common difference? We added it 3 times. What? I didn't put plus and minus. That's wrong. Come on. There we go. So make an equation out of what you see right there. If you don't know how to make an equation, then you should write this down. 3 plus 3d equals what? 3 plus 3d equals what? 24. That's the equation you should have in your notes right now. 3 plus 3d equals 24. Solve it for d. And the common difference is 7, right? You subtracted 3, you got to 21. You divided by 3 and got 7. Okay? How do I use that to find the first term? Subtract. Yeah, we're going backwards. So what is the first term? -4. So now we can come up with the explicit formula for an arithmetic sequence. Remember I said in the notes, it's basically the point-slope form of the equation of a line. Yes, you need to know the first term, and you need to know the common difference. Please fill in those 2 blanks. What do we put in the first one? -4. What do we put in the second one? I do not require that you distribute the 7 and add like terms. You can stop right there. Okay, now don't break the computer screen while you're trying to crack your neck. Okay, I can just see that happening. Yes. You mean instead of the 7 being on the other side of the parentheses? Is that what you mean, like over here? Am I understanding the question? Okay, all right. I do notice in there, like the blue box and the notes, they put the D on the other side. I don't really see the point of why they would do that. You know what? I will say this. Here's why I think they do that. Do you know how many kids add -4 and 7 together to say that it's 3 times n minus 1? Which is completely wrong, but they do it. So I think they put the D on the other side of the parentheses just to try to force the kids not to do that. I think that's the only reason. Okay, write your recursive formula. Write your recursive formula. It's the bracket one that has the 2 parts. Please write the recursive formula for this. Okay, what do we put in the 2 blanks? -4, yes, yes, yes. Plus 7, yes. Okay, we're going to repeat this process, but this time we're going to make an assumption that of the 5 terms that we started with, we're no longer dealing with an arithmetic. We're dealing with a geometric. So this was all my arithmetic stuff. But now, so we need to figure out a multiplier to get us from the 2nd term to the 5th term. How many times are we multiplying by r? 3 times, right? So what kind of equation would I need to write in order to make that happen? 3 what? No, I think you're on to something. What do you think? Touchdown? No. Okay. We could do this. We could go 3 times r times r times r, or 3r cubed. I heard a couple of you say cubed. You were right. 3r cubed equals 24. Go! 3r cubed equals 24. Okay, what did we get for r? 2 is correct. Took the cube root of 8, you got 2. So now we know that the multiplier is 2 each and every time. Anybody not understand what we just did? We multiplied by r 3 times, and that's the same thing as taking 3 times r cubed, and all we did was divide and take a cube root. So tell me what the first term is. Okay, you got about 20 seconds to talk to your neighbors and figure out what that first term is. Talk to your neighbors. It means you will have to open your mouth. Like they do in Congress, talking across. Trying to get these kids to open up. What did this guy say? Oh, not listening.
I wasn't listening to him. I was thinking about this.
Okay, good. But you need to talk. Okay. Got a question. What did she say? So don't tell me what you think.
So it's 3 times.
Did you actually ask?
The power of.
Did you ask him? No. Did you find out what it is? Oh, come on.
Because it's going to be back one.
All right, what did he say?
He was talking about, yeah, 1.5.
That's right.
3.
All right, Ms. Bogemeier, what did Ms. Jones say? I don't know what she said. Clever.
Exactly.
It's true. All right. I don't want to know what you think. How would you agree with that?
Okay, good.
I don't care whether you write it as a fraction or a decimal, 1.5 or 3 over 2. It's okay either way. I do want you to talk to each other sometimes in those situations. All right, so let's see here. We've got the next term is equal to the first term times the multiplier to the n minus 1 power. What goes in the first blank? 3 over 2 or 1.5, whichever you prefer. I don't care. I don't care if you want to write the fraction. That's good for me too. And then what goes in the next one? 2, the multiplier, right?
Oh, wait.
The multiplier. Yeah, no excuses. All right, how about that? Fill in the blanks of the recursive. What should go in the first one? 1.5. Excellent choice. And what should go in this second blank? 2. Yep. Any questions on that? Once we found the first term and the common multiplier, we had everything we needed to write either one of the formulas. Okay, now, don't get hung up on example 8. Example 8 talks about you need to stay with me. These next 3 minutes are mine. Now, don't get hung up on changing my calculator to sequence mode. Folks, can you graph y1 equals x squared minus 1? Do you know how to do that on a calculator? Yeah, you already know how to do that, right? Now, the important thing that you understand about sequences is the domain. What's the first number you can plug into a sequence? 1, right? Because you're looking for the first term. What's the second number you plug in? 2, and a 3, and a 4, and a 5, and there's never going to be a 2.57th term. There's never going to be a 0th term or a negative first term. It's always going to be a domain of what we call the natural numbers. 1, 2, 3, 4, 5, 6. That's why there is an actual calculator mode called sequence mode that you can flip your calculator over to if you really want to do that. I don't really think there's a point to it because guess what? I know that you can do this. You can graph an equation that follows a parabolic pattern. You can hit the trace button. You can type 1, 2, 3, 4, 5 if you need to know some numbers. What's more important to me is that you understand the shapes so that you can tell me things like, do you think this one's going to converge or diverge? What do you think about this? As the limit as n goes to infinity of n squared minus 1. What do you think? Look at the picture. As we go far to the right, what do you think's happening? Is it getting close to a single number? No, that's the important part to me. I want you to be able to look at this and say, oh, that one diverges. There is no limit. Or, if you think it converges, what is it getting close to? And we've talked about a lot of these things when we did rational functions. Folks, I don't think you need to use a graphing calculator to plug in numbers. I mean, look at this. 3k minus 5. Do you know how to plug in a 1? There's no need for a graphing calculator for that. Or a 2 or anything like that. What about this second one? It's a recursive pattern. It starts with -2. Do you know how to add 3? I bet you do. It's not tough. And you don't need a graphing calculator for that. And we don't need to worry too much about the Fibonacci. That's a cool sequence, but it's not the most important thing for us. Yeah, it is. It's pretty cool.